Black holes don't suck. That's the first thing scientists wish you'd forget. If our sun became a black hole tomorrow, same mass, just crushed into a sphere a few miles wide, the Earth wouldn't get pulled in at all. We'd keep orbiting exactly as we do now, just in the cold and the dark. A black hole isn't a cosmic vacuum cleaner. It's something far stranger. It's a place where the rules you've trusted your entire life simply stop applying. Start with the edge. Every black hole has a boundary called the event horizon, and it isn't a wall or a surface. It's a line drawn in nothing. Cross it and the escape velocity, the speed you'd need to get away, becomes faster than light. And because nothing in this universe outruns light, crossing that line means you are never coming back. Not your ship, not your scream, not even the light from your own face. From the outside, here's what's truly bizarre. If you watched a friend fall in, you would never actually see them cross. Time near a black hole slows down so severely that you'd watch them freeze at the edge, dimming, reddening, stretched across eternity, hanging there for the rest of the universe's life. To them, they fell in instantly. To you, they fall forever. Both are true. That's not science fiction. That's relativity, tested and confirmed. Now go deeper to the part that broke physics itself. At the center of every black hole, the math predicts something called a singularity, a point where the entire mass is crushed into zero volume. Infinite density, infinite curvature, and here's the uncomfortable secret physicists rarely say out loud. Nobody actually knows what's there. A singularity isn't a discovery, it's the sound of our best equations screaming. When general relativity spits out infinity, it's not describing reality, it's confessing that it has hit its limit. Something is happening at the heart of a black hole that our deepest theory cannot describe at all. There is a hole in human knowledge shaped exactly like that point, and it gets worse in the most wonderful way. In the 1970s, Stephen Hawking proved that black holes aren't even fully black. They glow. Faintly, agonizingly slowly, they leak energy into space, now called Hawking radiation, which means black holes evaporate. Given enough time, vastly longer than the current age of the universe, every black hole will shrink, fade, and vanish entirely. But that creates a paradox so deep it's still unsolved today. If everything that fell in is encoded in the black hole and the black hole evaporates into random radiation, where did all that information go? The universe has a strict rule: information can never be destroyed. Black holes seem to break it. Physicists have fought over this for 50 years. Hawking himself changed his mind. We still don't have a clean answer. Then there's the question of size, and the numbers stop making sense. At the center of our galaxy sits a black hole called Sagittarius A, 4 million times the mass of our sun. We've photographed it, but that's a pebble compared to the monsters. There's one called Ton 618 that may hold 66 billion solar masses. Its event horizon is so vast that light, moving at the only speed it knows, would take weeks just to cross it. How do these things even form? They're so big, so early in the universe's history, that astronomers genuinely can't explain how they grew that fast. The math says there wasn't enough time, and yet there they are, sitting in our telescopes, daring us to explain them. Here's where it turns truly philosophical. Spin a black hole and they all spin, and the geometry of space inside contorts in ways that, on paper, allow for something astonishing. Some solutions to Einstein's equations suggest a rotating black hole could contain a ring instead of a point, and passing through that ring might lead somewhere else entirely. Another region of space, another time, maybe another universe. Now, physicists are careful here, and so am I. This is what the equations permit, not what we've proven. The interior might be unstable. It might destroy anything that tried. But the unsettling fact remains. Our most successful theory of gravity does not forbid a doorway. It only stays quiet about where it leads. And consider what black holes do to time on the grandest scale. Fall toward one, and from your perspective you might watch the entire future of the universe unfold above you, sped up, billions of years flashing past in moments, stars being born and dying like sparks, all in the time it takes you to reach the edge. A black hole isn't just a hole in space. It's a hole in time. It's a place where past, present, and future lose their meaning, where the universe's oldest law, that information lasts forever, comes into open conflict with its own creations. We've mapped the planets. We've decoded starlight. We've heard two black holes collide a billion light-years away. But the thing at the center, the singularity, the part where reality itself runs out of rules that we have never touched and maybe never can. So if a black hole is a place where space becomes time, where information might vanish, and where our finest equations simply stop, what does that tell us about the universe we thought we understood?